Hello, my name is Noel, and this is my third and final project for pre-calc, my introduction to limits. So, or not my introduction to limits, just the introduction to limits. That's a bit of a wording thing, but essentially, just a general overview of what this is. You're going to be learning what a limit is and how to find it along a graph or an equation. So not as many defined terms or vocab as I like to usually use, but an undefined term is an expression that when a value is substituted into an equation, it will not give a number. A value can be undefined if it is outright stated or makes the denominator of an equation equal 0. So examples of how to tell if a number is undefined, if it straight up says like x is not equal to 5, or x cannot equal 5 in an equation, or something like x plus 1 and then x plus 1, it will not be defined at x equals -1, because if you plug in -1 into x, you're going to get 0 in the denominator, essentially. And a limit is a value that a function approaches as the input approaches the same value. So it's kind of essentially asking you, like, say a point, we'll just say like 2, for example, and then we'll just pretend that there's a graph. As you approach 2 from the left with the x values, what number are you going to get closer to? Oh wait, no, not that. That's my bad. I drew this wrong. That would be something else. Here, let me retry this again. So, yeah, as x essentially approaches 2, approaches 2 from the left, what number are you going to get? So, like, -1 and then 0 and then 1, they're going to be progressively getting closer to the y value of whatever 2 is, and then same with 3, 4, 5, and 6, except from the right. So, if they are the same, usually that just means the limit is just one thing, but if they're different, then it will be no solution, essentially. So, for example, if from the left it's going to be at 1, but from the right it's going to be at 2, then that would just mean there's no solution. Here we're going to start off with an example one. So f of x is equal to x minus 2 and x minus 2. Now, just simplifying this to straight up 1 is certainly almost correct. However, you have to remember that when you plug in 2 into this equation, you are going to get 0 as a denominator, or you're going to get an undefined term. So let me show you. So we're going to plug in 2 minus 2, and then 2 minus 2, and you'll see that you will get essentially an undefined term here because the denominator equals 0. So what this would look like written, or a bit more simplified, is f of x is equal to 1, x does not equal 2. And then here I'm going to show you what that would look like on the graph. So essentially just saying at all values of 1, or at all values of x, it is going to equal 1 except for 2. So you put a little hole here, and essentially you can tell that at no matter what value except for 2, it is going to equal 1. And then there's this little hole here at 2 to signify that it is undefined specifically at 2. So as for a limit, again, you want to look, if you want to find the limit as it approaches 2. So, see, so as from the left, -1, it's at 1, 0, it's at 1, 1, it's at 1, and then 3, 1, 4, 1, and then it constantly gets closer. You can tell 0.5, 1, and it's going to eventually it's going to be 1, essentially. just because it's going to constantly get it closer to 2, which is at 1, essentially. Next example I got, so g of x, oh shoot, that was a bit of my bad. G of x is equal to, let's see, here, x squared if x is not equal at 1, and when x does equal 1, it's at 2. So this would just essentially be a normal parabola, yes. So as just look like straight up normal parabola, and then specifically though, when on 1 is not along this parabola. When you plug in 1, it's going to get 2. So when you plug in 1, you're getting 2 instead of just what you get when you plug in 1 into the parabola. So what this would look like is, so 1, 4, and then just shoots up, 1, 4, and shoots up. Again, pretend that my lines are much straighter and it probably hits certain points a bit better, but remember that at specifically 1 along this parabola, it is undefined, so you would show that by drawing the hole. However, if you were to plug in 1, instead of it being undefined, you're going to get 2 instead. So to show that, you would essentially plug this in. So it essentially saying just all values of x are going to be along this parabola, with the exception of 1, which is undefined along the parabola. However, if you were to plug in 1 into the equation, you would get 2, essentially. So let's talk about limits for this one. As you approach 1, so again, you want to look at just as you approach from the left and as you approach from the right. 1/2, square that, and then 3/4, square that. You're going to be slowly getting closer to 1, essentially. And same, or essentially getting closer to 1, which is the y value of here, of 1, essentially. And then, see, look, 2, and as you constantly square it, you're getting closer and closer to 1. So it would equal 1. Thank you for listening to my presentation.